Good evening. Study with Apala Engineering and General Geology Parvin Singha book. So in chapter 10, today start the study of minerals. So crystallography, according to this यहाँ इस crystallography का study किया जाएगा. Introduction. A crystal may be defined as a solid polyhedral forms of a substance bounded by some smooth geometrical surface called faces. Crystals may be natural or synthetic. Natural crystals occurring in thousands of varieties are formed into the earth from natural fluids by their coolings under different condition of temperature and pressures. Most minerals occur in the forms of crystals or crystalline aggregate. Synthetic crystals are obtained by cooling saturated solution under controlled condition of temperature and pressure. In either case, the process of formation of crystal is called crystallization. It results in a very orderly and perfect internal arrangement of the atoms of the element or compounds during the cooling phase. The external shape of a crystal is therefore only an outward manifestations of the regular internal atomic structure. Crystallography is that branch of science which deals with all the aspect of crystals. That is their formations and from the melts and their internal structure and their external shapes or morphologies. And elementary knowledge of crystallography is essential for all those who have to deal with the minerals in one way or another, such as mining engineers and civil engineers, metallurgists and engineering geologists, for mineralogists and geologists. An in-depth study of crystallography is indispensable element of crystals. In the study of crystals, few definite characters are sought for. These include crystal faces, the angles between the crystal faces, the relationship of these faces with reference to certain assumed line passing through the crystals, and also the arrangement of these faces. All these characters form element of crystals. These are discussed below briefly. Crystal faces. Any crystal will have one or more types of external surface which may be regular or modified geometrical figures such as a square, rectangle and a triangle and trapezium, or a rhombus. Such an external regular surface on a crystal is called a face. A crystal may have only two faces of the same geometrical shapes, or it may have up to 48 faces of a combinations of a geometrical shape. A given number of similar faces on a crystals when studied together make a forms in figure. So obviously there are three crystals forms A, B and C on the same crystal. So in figure. So don't forget to make a figure. In interfacial angles, there are always a number of faces on a crystal. The angle at which any two adjacent faces are placed on the crystals with respect to each other is called an interfacial angles. A Danish scientist and Steno observed in 1869 that the interfacial angles for all the faces of a particular mineral species are always constant. This observation was later on in enunciated as a law of constancy of interfacial angles and stand as below. The angle between the corresponding faces of crystals of a given substances measured at the same temperature have a constant values in respective of size, shape and number of these faces. Since 1869, the validity of this laws, which is considered the first fundamental law of crystallography, has been established for all the substances that are crystallized. A simple instrument used for the measurement of interfacial angles is known as a goniometer या goniometer भी कहते हैं. It is simply a para protector having a rotating bar pivoted at its center. So for taking measurement, the edge between the two faces of the given crystal is made to lies parallel to the axis of rotations. The angle between the two faces of the given crystal is made to lie parallel to the axis of rotation of the bars, whence the protectors has double graduations, internal and external measurement with the goniometer will give two values, total beings 180 degree. Of these two values, one is called the internal solid angles and the other is external angle between the faces and the extensions of the others, and so this latter is termed the polar angles and is generally mentioned as an interfacial angle. Measurement with the contact goniometers are accurate to the extent of half degree for greater accuracy. Optical goniometers such as one circle reflecting goniometer or theodolite geometers are available. So in figure, so please practice on your plain paper, make rough. फर्स्ट ऑफ ऑल आप रफ बनाइए, फिर दूसरी बार रफ बनाइए, तीसरी बार में आपका फेयर आ ही जाएगा, क्योंकि फिगर आप जानते ही हैं कि अगर कोई भी डायग्राम बनाते हैं तो वो माइंड में बहुत अच्छे से बैठता है और लंबे समय तक याद रहता है. तो इसलिए जब आए तो थ्योरी और डायग्राम और एग्जाम्पल बिल्कुल मत छोड़िए. सिमेट्री. By crystal symmetry is understood a sort of regularities in the arrangement of faces on the body of a crystal. So for instance, if a crystal could be cut into two halves, one half being the mirror's image of the other half, it has a symmetry with the reference to a plane along which it has been cut or imagined to be cut. Symmetry is the properties of fundamental importance for crystals. It can be studied with reference to three different characters commonly called element of symmetry. These are a plane of symmetry, an axis of symmetry, and the center of symmetry. A plane of symmetry, any imaginary line. n means है कि any imaginary plane है passing through the center of a crystal in such a way that it divides the crystals in two exactly similar halves is called a plane of symmetry. In other words, a plane of symmetry is said to exist in a crystal when for each face edge and or solid angles there is another similar face edge or solid angle occupying identical position on the opposite sides of these planes. A crystal may possess one, two, or more planes of symmetry, the highest numbers being 9, and occurring in the normal class of isometric system. And so further, planes of symmetry may be described as axial, horizontal, vertical, or diagonal, depending upon its positions with reference to the outlines of the crystal. So in figure. Thank you.